Let's find the domain, x-intercept, and vertical asymptotes of these three logarithmic functions, and then we can use that information to sketch their graphs. Recall that the domain is the set of x values we can plug in. The x-intercept is where the function passes the x-axis, so where y is equal to 0. And a vertical asymptote is a vertical line that the function gets arbitrarily close to, but does not hit. Beginning with problem 1 and finding the domain, you must recall that the input, or what we call the argument of the natural log function, which in this case is x minus 1, must be positive. So to find the domain, just take that argument, x minus 1, and set it greater than 0. Then solve the inequality for x. If x minus 1 is greater than 0, certainly by adding 1 to both sides, we find that x must be greater than 1. So the domain is all x values greater than 1, which we could also write in interval notation like this. All numbers from 1 to infinity, not including 1, and of course, not including infinity. That's why we use the parentheses instead of square brackets. Next, the x-intercept. Like I said, this is where the function hits the x-axis, where its output is 0. So we take the function, ln of x minus 1, and set it equal to 0, and then just solve for x. To solve for x, we begin by exponentiating both sides. So on the left, we have e to the 0, and on the right, we have e to the ln of x minus 1. We're doing this because e and ln are inverses. So exponentiate both sides, and we'll be able to get rid of that natural log. Now on the left, e to the 0 is 1. And on the right, e to the natural log of x minus 1, well, e and ln cancel out, that was the whole point, so we're just left with x minus 1. So we have that x minus 1 equals 1, we can add 1 to both sides and find that x equals 2. So that's where this function passes the x-axis, at x equals 2. Now for the vertical asymptote, remember we said the argument of the natural log function has to be greater than 0. It can get arbitrarily close to 0, but it can't actually get to 0. So the vertical asymptote occurs where the argument is equal to 0. So we take the argument, the input of the log function, which is x minus 1, and set it equal to 0. Then we can solve for x by just adding 1 to both sides, and thus we find that x equals 1 is where the vertical asymptote is. Note that we could have jumped straight to that from the domain. We already know that x has to be greater than 1, so it must be at 1 where the vertical asymptote occurs. And then we can use all of this information to sketch this graph. You have to know that this is the general shape of the log function, but the other stuff comes from the work we did. We have this dotted vertical line at x equals 1 because we know that's where the vertical asymptote is. This function is going to get arbitrarily close to that vertical line, but it's never going to pass it. We also know that it intersects the x-axis at x equals 2. And of course, the domain is x greater than 1, so everywhere past x equals 1, the function is defined. Here's our second example, f of x equals ln of minus x. Again, we begin with the domain. Take the argument, or the input, of the natural log function, negative x, and set it greater than 0, because it has to be positive for natural log to be defined. Then, multiplying both sides of this inequality by negative 1, we get the domain. X is less than 0. So the domain is all x values less than 0, which we could also write like that. The interval from negative infinity to 0, not including negative infinity, and not including 0. And also, since we know the domain is x less than 0, we know it's when x is equal to 0, that's where the vertical asymptote is, which we'll mention again in a minute. For the x-intercept, we again take the function, ln of minus x, and set it equal to 0. Then just solve for x. You can exponentiate both sides to do this, or you could also say, we know that the natural log will be 0 when its argument is equal to 1. So you could just jump straight to setting the argument equal to 1. Now, it's not so simple if there's other stuff happening outside of the natural log function, but in this case, there's not. So we could just jump straight to taking the argument, negative x, and setting it equal to 1. Either way, of course, we find that x is equal to negative 1. And so that's where this function is going to intersect the x-axis. Finally, the vertical asymptote, we already said that's when x is equal to 0. That's the boundary, so to speak, of the domain. But you could also find it by taking the argument, negative x, and setting it equal to 0, which of course implies x equals 0. We then get this sketch. We've got that dotted purple line, the vertical asymptote, at x equals 0, and the x-intercept we know is at -1. You may ask, how do we know that the function looks like this instead of looking like this the way it normally does? Well, hopefully you know that negating the input, having -x, has the effect of reflecting the function across the y-axis, so you should anticipate a shape like this. On the other hand, we just know it can't be like this because, of course, the vertical asymptote. The function can't look like that. Plus, the domain is all of the negative numbers, so this branch that goes on horizontally forever has got to be going in the negative direction. All right, last example, f of x equals ln of 4 plus x. If you haven't yet, you might want to try this one on your own. I'm going to put the solution on screen now. For the domain, we take the argument 4 plus x and set it greater than 0. Subtract 4 from both sides, and we find the domain is all x values greater than -4. For the x-intercept, we can take the function ln of 4 plus x and set it equal to 0 and solve, or you could just jump straight to setting the argument 4 plus x equal to 1, in which case we solve by subtracting 4 from both sides and find that x equals -3. Finally, the vertical asymptote, that's just like the boundary of the domain. If x has to be greater than -4, our vertical asymptote must be x equals -4. This all leads to this sketch. We see it intersects the x-axis at -3. We got that vertical asymptote, a vertical line at x equals -4, and so the ln function looks like that. So those are a few examples of finding important characteristics in order to help sketch natural log functions. Let me know in the comments if you have any questions, and be sure to check out my Precalculus course and Precalculus exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.